Hello, this is the blockchain project for group HotVR. We have built a blockchain simulator.
So we'll first proceed with the introduction of the project. This simulator is designed to provide a hands-on experience in understanding the fundamentals of blockchain technology. While it is not an actual blockchain implementation, it correctly demonstrates how blockchain operates. This is built by Streamlit. For the UI, the simulator saves crucial blockchain components such as the chain, state, transaction buffers in the CSV file. Key functions include creating user, making transaction, checking balance, printing the blockchain, and mining transactions.
Let us look at the key features now.
First feature is create user. This function creates a user and adds them to the state. If it takes two input, user ID and initial wallet amount. As this is just a simulation, we give the user initial balance. Key pairs are not generated for any user for this simulation. It also checks for any individual user amount, that is negative amount. Existing user ID is also checked for unique user IDs. The functionality of deleting a user from the state is also implemented in our project.
Let us see the implementation now. So this is the Streamlit UI. We'll now create a user, let's say Karthik, and we'll give him 10 initial currency and then create a user. The user is created. Now if we again create Karthik as a user, we'll see that user already exists. And if we give any negative amount to some users, let's say Karthik1, and create a user, the initial amount is what it throws an error. We can see the implementation of the following function. So the create user function is here. It takes the user ID and checks if it's already in the state. Then it returns one error, which is user already exists, and if the initial amount is less than 0, it returns the second error, which is initial amount was positive. Apart from that, if everything is correct, the state stores the user ID and the initial amount, and the blockchain file is saved to the state is saved to the blockchain.csv file, and then it is returned.
Now let's move to the second key feature, that is transaction. Transaction can be submitted to miners to be added into blockchain. Every transaction is added to a buffer which holds all the pending transactions. User has to enter senders and receiver user ID and the amount to be transferred.
Let's see the implementation of transactions as well. So we select the transaction, make transaction option, and then we say Karthik is sending Alice some amount. Alice is constructed in the initial stage of the implementation, and let's say we transact 5 currency and then transact. The transaction is submitted to the miners, and the miners can mine it and add to the blockchain. If we add any invalid transaction to it, let's say Karthik2 is sending to Alice anything, the transaction will always be added, and even if we add negative amounts or anything, the transaction is already added. So this can be done, and the transaction is given to the miners. Let's see the next feature. The implementation is simple. The transaction is just added to the buffer, and the transaction is taken from the input, and it is saved into the blockchain buffer.csv file.
Now let's go to the next key feature, that is check balance. We can check our balance anytime we want. User can check their wallet balance using this functionality. User has to enter their user ID and the wallet balance is shown for the user. Invalid user ID throws an error. It is implemented through a simple query from the blockchain state.
Let us see the implementation. So we select the check balance function, and we enter a user ID, let's say Bob, and we check balance, which is 5 currently. We can check another as well, Karthik has 10, and if we do any invalid user ID, it shows user does not exist. The check balance function is implemented in the code here. So it just queries to the state and returns the actual balance or false if the user does not exist.
Let's move to the next key feature, which is mine a block. All the transactions added to the buffer can be selected from a list and the miners can add them to the blockchain. Miner has to enter their user ID to get the mining reward. Default reward we have set is 2-1. Proof of work is currently not implemented. Every transaction added is checked for validity through these checks: sender and receiver's existence and sufficient balance in sender's account. Error is thrown for invalid transaction, and this transaction is thrown out of the buffer.
Let us see the implementation of the mining as well. So we select the mine block option. We enter the miner's user ID. Let's say Alice is going to mine. All the transactions we added are shown here. We can select all the transactions. Let's say Karthik sent my Alice 5 currency. So, and then we mine it. So transaction is added to the blockchain. If we select any invalid transaction, let's say Karthik 2 sends Alice 5. So Karthik 2 does not exist. So it shows some transactions are invalid. We can also add multiple transactions in a block. Let's say we make some transactions. Karthik to Alice 1, and then Bob to Alice also 1, and then Bob to Karthik as well 1, and then we can add them together. Let's say Karthik is the miner, and we select these options: Karthik to Alice, Bob to Alice, and Bob to Karthik, and we'll mine them, and all the transactions will be added to the blockchain.
So the next feature is printing a blockchain. So blockchain can be printed on the screen using this functionality. User can see all the transaction added to the blockchain starting from the genesis block. Every block in the chain contains its content hash, and the contents contain the block number, parent block hash, number of transaction, miners, and all the transaction in the block.
Let us see the print blockchain function, and we'll also see the blockchain's data structure. So this is the first block, the genesis block, which we added. It has the block hash here, and its parents hash is NA because it's the genesis block. The block number is 0, and this is the transaction here, and the miner was Alice. The second block we created has the hash this, and the parent hash is the same as the genesis block, and then we can see the transaction count is 3, and all the transactions are shown here, and the miner is also shown here. So now we have seen the print blockchain implementation as well. We can go through the code as well. The Streamlit app is just the UI interface. So here all the options are created through Streamlit, and every input we give to the UI is given to the blockchain file, and it simulates the blockchain as well. So the blockchain file has many functions. The initial function just starts the chain state and buffer. We add Alice and Bob in the initial state, and then we load all the previous state from the CSV files. The CSV files contain all the pending transactions. The blockchain.buffer file contains pending transactions. The blockchain state contains the user ID and balance of everybody in the blockchain, and the blockchain data contains all the blockchain itself. The next function is the hash block, which generates the hash for a block, and CSV encode just converts the CSV file into a UTF-8 encoding. The make block makes a block function makes a block where all the blockchain block contents are created, and then the block is hashed and stored into the block is returned. IsValid function checks the validity of a transaction. Update state changes the balances of the users. Create user is used to create a new user. Delete user is used to delete an existing user. Add transactions to buffer, add the transactions. The miner reward is just adding extra amount to the miner reward to the miner's account. These are all the helper functions, and mine block is the function which mines a block. It checks for all the invalid transactions. All the invalid transactions are stored in the invalid transaction list, and then it also checks if the total amount for if multiple transactions can exceed a user's balance, then all those transactions are also deemed invalid. And then if none of the transactions are invalid, we update the state of all the users whose transactions are being made, and then we add it to the chain as well, and then we store the chain state and buffer to the CSV files respectively. These are also the helping function which help load and save states and chains and buffer to the files and from the files. We can reuse some important notes from this assignment as well. The transaction will be represented with positive numbers for deposit and negative numbers for withdrawals.
Additionally, we enforce that the deposit amount is equal in magnitude to the withdrawal amount. This ensures that no money is created or destroyed during the exchange.
Transactions must ensure that the sum of deposits and withdrawals equals to 0. This means that tokens are neither created nor destroyed, maintain their total token supply.
The state of the system is updated to reflect the impact of transaction included in the child block, ensuring consistency and accuracy in account balance.
Additional implementation can be made of a consensus mechanism, such as proof of work or proof of stake, to ensure agreement on the state of blockchain among network participants can be added to the simulation. This addition would enhance decentralization and security. Thank you. This has been Group HotVR.